Hello guys, so we are back again, and in the previous session we have completed our first order linear differential equation, and in this session we are going to start with Bernoulli's differential equation. But before starting with the session, hope you have subscribed our channel Omega Pi IITJ and Gate so that we can bring more engineering mathematical content for you guys. Now before starting with the session, let's understand what is means what are the things which you need to know to understand Bernoulli's differential equation, its standard general form, and how we solve it. So let me write the topic, which is what Bernoulli's differential equation, right? Equation. Now this is an important thing. Why it becomes important, I will tell you. So the things which you should know: its general form. Its general form is nothing but, you have to remember its general form. It will be available in dy by dx plus p of x into y equals to q of x into y power n. Okay, so it will be available in this format. Now what you have to do to solve this, you know, in when we studied linear differential equation, its form was what? Dy by dx plus p of xy equal to q of x. We know to solve this. Okay, we know its solution, which is y into integrating factor equals to integration of integrating factor into q of x into dx plus c. So we know its solution, so we will try to create this in this format. For that we will try to remove this y power n. To do that, we will divide throughout by y power n. If we divide throughout by y power n, we will be having y power n dy by dx plus p of x. Here if y power n and here this is y power 1, so it will become y power n minus 1, and this will be q power x. But now the thing which has been in our favor is that q of x is now alone. But the thing which is not in our favor, that we have studied in linear differential equation that the coefficient of dy by dx or dx by dy should be always 1. Okay, we have seen problems also on that in the previous session. But here the coefficient is what? 1 by y power n. So what you have to do, always remember what happens in this is that what you are going to do, you are going to consider this 1 upon y power n minus 1. Always p of x attached part will always, you will consider what? V as a variable v, to eliminate this 1 by yn and create it into a new linear differential equation by substitution in general. So what we are going to do, let 1 by y power n minus 1 should be equal to v. If you do that, what you are going to get? If you differentiate this, you will get 1. If you move it up, it will become n minus 1. Sorry, 1 minus n, right? So here 1 minus n will come as it is, and y power 1 minus n minus 1 will become what? Minus n, and when it will come down, it will become 1 upon y by n. For your understanding, 1 minus n minus 1 will be there. Here dy by dx, we are differentiating with respect to x, into dv by dx. Okay, now what we want, you can see 1 minus n, y power n minus n will be left, and dy by dx equals to dv by dx, right? Now 1 by y power n into dy by dx into dv by dx, 1 by 1 minus n. Okay, so here you can see that we have got this thing which you can see here is nothing but this thing. So we can substitute this by this. So if we substitute this in this equation, what we are getting is dv by dx upon 1 minus n plus, now what we have substituted, y power n minus 1 as v, so we will substitute here p of x into v equal to q of x. Now to make its coefficient, one will multiply throughout by 1 minus n, multiplying throughout by 1 minus n. So if we do that, what we are going to get? dv by dx plus 1 minus n into p of x v into 1 minus n into q of x. Okay, so we are getting this. Now you can clearly see that this is a linear differential equation which can be easily solved because its coefficient is 1. Here p of x into this will act as your p of x. Okay, 1 minus n into p of x, this whole will act as your p of x. Here v should come, like there it was y, and here only x, f, q of x. Okay, this one is also correct. So it satisfies the condition of linear differential equation. Now our next job is to get. Now can you solve this? Yes, its solution will be given by similarly v into integrating factor. Its solution will be what? You can find the integrating factor of this, like you used to find the linear differential equation integrating factor, and then use that v into integrating factor is equals to integrating factor into q of x dx plus c formula to get the solution. Now, so you have understood what you have to do, what form you need to get in the end. The form will be what? F dash y into dy by dx plus p of x into f of y equal to q of x. How this form came? This is nothing but this format. If you observe, this was what? Our f of x, and if we take it as v, then we get f dash x. So here what mostly f of x will be available here, you have to take it as v, then you will get f dash y. Okay, f of x or f of y. Okay, then what you have to do, resubstitute the things, and then it will become linear differential equation, and then you will get your answer. Okay, which was like this linear differential equation, and you have to solve it using the formula. Now we are going to take questions on it, and then we will try to solve them so that you can understand it more properly. So for the now timing, means the theoretical part of this binomial theorem, Bernoulli's differential equation is little bit confusing. You will not understand, but if you solve questions, you will automatically get a detailed understanding of how to solve the problems. Like, let's take this problem, the first problem. The first problem which we are going to take is as follow, which says dy by dx plus y by 3 equals to e power x into y power 4. Now what your job is to get rid of this, because here q of x, remember here a function of x and here a function of only x should be there. There should be no y term. So what you are going to do, divide throughout by y power 4. Dividing the first two questions of this session we will write with proper statement, and after this we are going to write what things are important. Dividing both the sides of differential equation by y power 4. So what we are going to get, y power 4 into dy by dx plus here it will become 1 by 3 into y cube equals to e power x. So now one thing got correct, that here only x term is there, but here we have 1 by y power 4. But if you remember the format, f dash y into dy by dx plus f of y, okay, into y equals to q of x, okay, like that format. So here you will get f of y. So our f of y is what? 1 upon y cube, and this is our f dash. Okay, so we can do that. You can observe this basic thing. The moment you observe, keep it as 1, put 1 by y cube equals to v. The moment you do, if you differentiate it with respect to x, if y is there you have to differentiate it with respect to x, and if x is there you have to differentiate it with respect to y. What you are going to get, minus 3y by 4 into dy by dx equals to dv by dx. You are getting this thing. What you have to do, what you need, 1 by y power 4, so you will shift this minus 3 that side, which will give you finally, okay, I will write here 1 by y power 4 into dy by dx is nothing but minus 1 by 3 dv by dx. Right? If I am right, this is very correct. So what we can do, keep it as 2. Therefore put 2 in equation 1. We get what we are going to get. If we put this, we can substitute this by this, which will give me minus 1 by 3 dv by dx plus, here we have assumed 1 by y cube as v, so we will substitute that 1 by 3 into v e power x. We are getting this. Now multiplying, we need to have the coefficient 1. For that we will multiply it by minus 3. Multiplying throughout by minus 1, we get what we are going to get, dv by dx minus v equals to minus 3 e power x. We are going to get this thing. So now our job is what? This is what? A first order linear differential equation. So this is a first order linear differential equation of the form, you have to mention the form also, dv by dx plus p of x into v equal to q of x, where p of x is nothing but minus 1 and q of x is nothing but minus 3 e power x. Okay, after getting this, what our job is? Okay, this was the previous derivation part. Now what we have to get? We have to get integration p of x dx, because if you remember in linear differential equation, when we used to find integrating factor, p of x dx used to play a crucial role, so we need to get that. So integral p of x dx is nothing but integral minus 1 dx is nothing but minus x. So we got our p of x dx. Now therefore integrating factor is nothing but e to the power integral p of x dx, which is e to the power minus x. After getting this, what we are going to do? Its solution is v into integrating factor equals to integration of integrating factor q of x dx plus c, which will be v into e power minus x, which is our integrating factor, into e power minus x minus 3 e power x into dx, right? Plus c. Here e power x and here e power minus x, so it will become what? 0. So e power 0 is what? 1. We are left with v into e power minus x, which is nothing but e power minus 3 dx plus c integration, which will give us in the end. Now we know v value is what? V value is 1 by y cube. We will substitute here. So we are going to get e power minus x by y cube, here minus 3x plus c. This is our answer. Now let's take the second question. We will write that also with proper definitions, and then we are going to, in the next session, we are going to start with the main thing, okay, whichever required in the questions to solve. But we are going to do a large number of questions, so you will get a clear understanding. We are not going to do 2-3 questions, okay. We will take it to means we'll practice a lot, so that you don't feel uncomfortable in Bernoulli's differential equation. So the next question which we are going to take is this question. The question is as follow. The question says dy by dx plus 2y by x equals to minus x square into y square cos x. Okay, how you are going to begin with this question? First, try to get what I have to keep it on the right side and what I am to remove it. Here dy by dx, the thing which is in denominator, its function should be on the right side. So here x function should be on the right side, so I am going to divide throughout by y square. Dividing both the sides of differential equation by x square, by y square. If we do that, what we are going to get? 1 by y square dy by dx plus 2 by x into y equal to minus x square cos x, right? Now the coefficient of 1 by y square into dy by dx plus this should be 1, but if you remember we are going to make it 1 by substitution. We know here this format is nothing but f dash y into dy by dx plus f of y into y equals to q of x. So we know 1 by y is nothing but our what, f of y. So put 1 by y equals to v. The moment you take that, what is going to happen, this will be what, minus 1 by y square if you differentiate it with respect to x into dv by dx. You are going to take 1 by y square into dy by dx and move this to that side. Therefore what we are going to get, 1 by y square into dy by dx is nothing but minus dv by dx. The moment you get this, what you are going to do, keep it as 2, keep it this as 1. From put, okay, put 2 in equation or differential equation. In equation 1 we get what we are going to get. If we put this, we will substitute this by this, so minus dv by dx plus what we have assumed 1 by y is v, so 2 by x into v equals to minus x square cos x. Now since the coefficients of dy by dx should be 1, so multiplying throughout by minus 1, we get what we are going to get, dv by dx minus 2 by x into v is x square cos x, right? After this what we are going to do, this is a linear differential equation and we can solve it by finding its integrating factor, and we know the formula for its solution. So this is a first order linear differential equation of the form, what is the form, dv by dx plus p of x into v into q of x. The moment you do that, where p of x, can you tell me what is the p of x? It is nothing but minus 2 by x, and q of x is nothing but, it is minus x square, okay, which has become plus x square cos x. So you are getting this. After this, you know you need to get integration p of x ds because it will come as a ingredient in your integrating factor. So let's try to get that. So integration p of x dx is nothing but integration minus 2 by x dx, which is minus 2 log x, which is nothing but log x to the power minus 2. Now therefore integrating factor is what, e to the power integral p of x dx, which is nothing but e to the power log x power minus 2, and here it will become x power minus 2, which is nothing but 1 by x square. So we got our integrating factor. So its solution is v into integrating factor bracket integrating factor into q of x dx plus c, which is v into 1 by x square into integration of 1 by x square into x square cos x dx, which is our q of x plus c. We are going to get v upon x square. This will become integration of cos x into dx plus c, and we know the v value, which is 1 by y. We are going to substitute here. Remember, you have to not keep your v as it is, you have to substitute the v value in the end. So 1 by y x square, this will become what, sin x plus c. This is your answer. So in this session we have completed 2 questions and understand the basic definition of Bernoulli's differential equation, and we have solved questions and understand it how to proceed. So in the next session we will take some more problems. Till then, practice these problems and see you in the next session.